Hi everyone, in this video we're going to go through a few solutions for a quiz on sequences and series for Y12 2 unit. This is mostly in preparation for their assessment task which is next week, but of course this will be used in future years as well. So going right into it, this first question we have consider the series -3 plus 1 plus 5 going on. So first we need to do is show that it is arithmetic. So arithmetic, as we know, means that it has a common difference. It's increasing through addition or subtraction rather than multiplication or division. So to show that it is arithmetic means we just need to show that a common difference exists. So the way that we can do that is we're just going to get t2 minus t1. So we're going to do the second term minus the first term, which would be 1 minus -3, which equals 4. And then if I do t3 minus t2, so basically the third term minus the second term, 5 minus 1 also equals 4. So what we're seeing here is the common difference is staying the same for those first two terms. So therefore the common difference exists, I guess. And because there's a common difference and it's 4, therefore it's an arithmetic series. So the main property of arithmetic series is that there is a common difference. So if you can show that there is a common difference, therefore it's an arithmetic series. Next, we want to find the 34th term in series. So this is just using your Tn formula, which will be on your formula sheet. So you remember, so we have T34 would equal -3 plus 4 lots of 34 minus 1. Because you would remember the Tn formula is A plus D times n minus 1. So I'm just subbing in all those bits. So I guess I probably should go back to the top and we'll talk about what all the things are. So A equals -3 because that's the first term. D equals 4 because that's our common difference. And in this question we're just trying to find what happens when n equals 34. We're trying to find the 34th term, so we just subbed all those numbers in. And then when you put that into your calculator, you'll get 129. So we're saying that the 34th term in that is 129. Now, of course, with all these series questions, you could have just added 34 times and eventually got 129, and that would work. The whole point of these formulas is to make it easy. That's the whole point of this topic, to get these series and sequences and make it a bit quicker. And then lastly, we want to find the sum of the first 34 terms. Now there's two formulas for this. The way that I'm going to be doing it, seeing that we already know what the 34th term is, that means we can use the quicker formula. So we know that Sn equals n over 2 a plus l. So there is also the longer formula where we don't know what the last term is, but because we just found in the previous question what the 34th term is, that means we do know what the last term is. So we're just basically going to sub into that formula. So we have S34 equals 34 over 2 -3 plus 129. And when you put that into your calculator, you get 2,142. And there's the answers for that. And again, just like with all these sequences and series questions, you could have actually just found all those 34 terms and add them all up, and that would work, but again, that'll take a while. We want to make it quicker. Question 2, we want to evaluate the following expression correct to two decimal places. And this is a sigma, so it's meaning we're starting at 2 and going to 5. We're going to keep subbing in n equals 2, n equals 3, n equals 4, n equals 5, and just finding what that answer is. So if we were to kind of sub this in, if I were to sub in n equals 2, well 2 minus 1 is obviously 1, so we've basically got ln 1. Then if I subbed in 3, 3 minus 2 is 2, so plus ln 2, plus ln 3, plus ln 4. Okay, because what I've done is I've subbed it in 2, 3, 4, and 5. Because the top number of that sigma is 5, that's their finishing point. And this isn't a geometric series nor an arithmetic series, so you might think that, oh, well, you know, that's going up by 1, so it's an arithmetic series. But ln 1 Like, so if we were to check if it's an arithmetic series, if we did ln2 minus ln1, and then ln3 minus ln2, it wouldn't be the same. So it's not an arithmetic series. Same reason if we check for geometric series, it wouldn't work. So there's only 4 terms here, so just put it into your calculator. It's actually quite simple. So you just do ln1 plus ln2 plus ln3 plus ln4, and you'll get approximately 3.18 to the 2 decimal places. So that's why it's only 1 mark. It's really just realizing what does sigma notation mean, subbing the numbers in, putting into your calculator, there you go. So it was only 4 terms. I mean, this question wouldn't be very reasonable if I asked you to go up to like the 20th term, because then you'd be adding up, 18 or 19 different terms, so we wouldn't do that. Next, question 3 is consider the geometric series. So in this question, it's already told you that's a geometric series. That's useful, because now that you know it's a geometric series, it means you know there's a common ratio, and that's what the first question is asking us to do. You also know that you can use all our geometric series formulas as well. So just make sure you read the question. If it tells you it's a geometric series, then it's already done all that. So here, first I need to find what the common ratio is. So remember, to find the common ratio is we just get any term and divide it by the term before it. So if I were to do T2 divided by T1, that would equal negative 1 over 3 over 1 over 9. Make sure you remember that negative. The second term is negative 1 over 3. It's not positive 1 over 3. So make sure you get that. And when you do that, you'll get negative 3. Okay? So that means your common ratio is negative 3. Also, because our ratio is greater than 1, the absolute value of it is greater than 1, that means we know it's a divergent geometric series. So the numbers are getting bigger rather than getting smaller. And so the question now is asking us to find S7. So S7 meaning we want to find the sum of the first 7 terms. And again, you could just find the first 7 terms and add them all up, and it wouldn't be too unreasonable to do that for 1 mark. It would be a bit long though. So it's the kind of thing that you can do at the end of the test if you completely forgotten how to do it. Or we can just sub it into the formula that we have in our formula sheet, making sure we're using the right one. So we're using divergent, so the Rn comes first. So should just go back. Again, just let's list out what the key things are. So we have A equals 1 over 9. We just found that R equals negative 3. And here we're saying that N equals 7. So we're just going to sub all those into the Sn formula. So we're going to have S7 equals 1 over 9, negative 3 to the power of 7 minus 1 over negative 3 minus 1. Now just really be careful for a second here that you put the negative 3 in brackets. Remember, with our calculator, if we don't put that negative 3 in the brackets, what it's going to do, it's going to do 3 to the power of 7 and then put a negative in front of it. In this case, it actually won't change anything. It will give you the same answer. But if it was an even power, say like it was to the power of 8, so we're trying to find S8, it should end up as a positive. But if you don't put in the brackets, it'll do 3 to the power of 8 and then put a negative in front of it. So that will be a mistake. So just make sure you keep that clear. Especially when R is a negative, make sure you put it in brackets. But you might as well put it in brackets all the time, then you'll be fine. Anyway, and then so once you put that into everything, you get 547 over 9, which can also be written as 60.7 repeating, if you want to do that as well. Either way, it's fine, but yes, just subbing it in. And then lastly, what we need to do is show that 273 is not a term in the series. Now this question is actually a bit trickier than what it might seem initially, because if I were to, what we're going to do here is going to use that log thing. We're going to set up the equation 273 equals 1 over 9 power of negative 3 to the power of n. Okay, that's using the Tn formula. We're trying to see if 273 is in that series. And if we were to do that, start doing the logarithm stuff, we'll eventually get a log base negative 3. Which will be ln negative 3, which actually can't work. So in this question instead, whenever you are checking to see if a term is part of a geometric series, what you can do as kind of like a cheat is make R positive and then just start solving it from there, and then we see whether it's going to be or not. So let's just make R positive. So if we were to sub it in properly with our positive version of R, we're going to have 273 equals 1 over 9, 3 to the power of n. And then so what we're going to do first is move 9 over, so we have 240, 2, 4, 5, 7 equals 3 to the power of n. And then so now we start doing that log thing, so remember base becomes the base. So the base becomes the base, subject becomes there, and index becomes the power. And now we don't know how to do that log base 3, so we'll use our change of base rule. So we got ln 2, 4, 5, 7 over ln 3 equals n, and therefore n equals 7.105 ... And as we know, because n is not an integer, therefore like the 7th term would be a little bit below, was it 273, and then the 8th term would be a bit above it. So that means we've skipped to 173, so we'll just say not an integer, therefore not in the series. Alright, so that works because we made it positive 3. Now, let's say, just for instance, that because we changed to positive 3, and let's say n did equal 7, so it was an integer, what we'd then have to do then is check to see, what we would have found there is it might be in the series, but we don't know for sure, so you'd have to then check the alternation between negative, positive, and see if it fits in the pattern of negative, positive as well. I'll talk more about that later if you want to ask me about it, but like the reason why I'm not going into too much detail now is I've never seen that HSC or in textbooks, I'm not even sure if it's in the syllabus, whether they'll be asked questions like that, like when you have to check the alternation. But I guess the hint for this particular question is if you're checking to see if a term is in a series, in a geometric series, just make R positive, and then you'll be able to tell that's just not an integer. And then we'll go from there. So, question 4. Consider the series and again, so we haven't been told in the question just yet that it's arithmetic or geometric. Of course, question A is saying show that it's convergent geometric series. What you need to do here is notice that it's asking for 2 things. First of all, it's showing that it's a geometric series, I mean it's the other way around. We need to first show that it's a geometric series, but we also need to show that it's a convergent geometric series. Meaning that we'll need to show that there is a common ratio, and that common ratio, the absolute value of it is less than 1. So let's just get right into it. So to find our, just first of all show that it is a geometric series, is we're going to do just like we did in that very first question, except with without subtraction, we're going to do division. So if I do t2 divided by t1, that's going to equal 3 over 4 over 3 over 2, which equals 1 over 2. And then similarly, if I did t3 over t2, that would equal 3 over 8 over 3 over 4, so it equals 1 over 2. So again, that common ratio exists, so we'd say common ratio exists, and absolute value of R is less than 1, because the question is also asking us to show that it's convergent, and we see that, you know, the absolute value of half is indeed less than 1, so therefore it's a convergent geometric series. Alright, so to show that it's a geometric series, there needs to be a common ratio. To show that it's a convergent geometric series, that common ratio needs to be less than 1. The absolute value needs to be less than 1. So you just need to show those 2 things and you're good to go. and hence find the limiting sum of the series. So limiting sum, remember, means we're trying to find the infinite sum here. So we're trying to find what happens by adding up an infinite amount of numbers, and this only works with convergent geometric series. So here we have a equals 3 over 2, this is the first term, r equals r, like we just did. So when we sub it into s infinity, or limiting sum or whatever, remember that's a over 1 minus r, so we've got 3 over 2 over 1 minus a half. We just put all that in, you get 3. So what we're saying there is, if you were to add these infinite amount of numbers in this series, it would equal to exactly 3. So it's kind of a bit abstract or theoretical, but we're not saying it's approximately 3, no, it will be exactly 3. Going to question 5 now. So this, the next 3 questions are a bit more application-y kind of questions, rather than just say, here's the series, do this, here's the series, do this. So Heather decides to swim every day to improve her fitness level. That line has no meaning in the question at all. It's kind of just giving context, so you can kind of ignore it. On the first day, she swims 750 meters, and each day afterwards, she swims 100 meters more than the previous day. Alright? That is, she swims 850 on the second day, 950 on the third day, and so on. So write down a formula for the distance she swims on the nth day. So what we need to do here, first of all, is we need to decide whether there's going to be arithmetic or geometric. And fairly simple here. Yeah, it's arithmetic because we're increasing by 100 each day. What might help with these application questions is always start off by writing the first few terms of the series, because that way you can kind of see what's happening. So on the first day, T1, it's 750. On the second day, T2, it's 850. On the third day, it's 950. On the fourth day, it will be 1050, and so on. Alright, just writing down the first few terms really does help. It's a really good tip. So now that you're looking at that, we have A equals 750, we have D equals 100, and then we can just go from there. So we need to write down the formula for distance. So putting this into our formula, TM formula, I'm just going to put it straight in. So we have A, which is 750, D, which is 100, and then N minus 1. The question's not asking us to find any particular day, we're trying to find the nth day, so we just keep it in terms of N. So how far does she swim on the 10th day? So quite simply, we're just going to sub in N equals 10. So I it all. So T10 equals 750 plus 100, 10 minus 1. Sub that all in, 1,650 meters. Might as well answer in whatever it was telling us to do, seeing that these are in meters, do meters. And then lastly, what is the total distance she swims in the first 10 days? Again, this is, you've got the sum of an arithmetic series, and it's asking for the first 10 days. Again, we just found what the 10th day is, so we can just put it into 10 over 5, A plus L. I'm just going to use the slightly longer formula, just because we didn't do it earlier. So the longer formula is, say we didn't know what the last term was, which we do from the previous question anyway. We subbed it in, we've got S10, 10 over 2, right, because that's n over 2, 2, we write this all in and then we'll talk about it. So remember, this is 2 times A. That's your D, and that's n minus 1. So putting all those numbers in, and then when you put that in, you get 12,000. Alright, so that, remember, that's not saying that on the 10th day she swam 12 kilometers, 12,000 meters. What she's saying that in the 10th day she swam that in total. So you add up all the distances she swam in those days. Alright, question 6. Question 6 is we're now talking about these annuity problems where it's an application series. So let's just go through all the key bits, because a lot, as you see, there's a lot of writing here, and you guys keep saying you hate all this writing, so let's look at the key bits. So basically, that's entirely useless, I'd say. there. We don't really need it. So invest $80 at the beginning of each month. That's really, really important. Note that we're talking about the beginning of each month as well. Right, so it's super important. And the money is invested at 6% per annum, compounded monthly. So remember, compounded monthly changes a whole lot. We have our per annum rate. We don't want to use a per annum rate because we want it in months. So we're going to divide that by 12. So 6 divided by 12 is 0.5. So we have 0.5%. Do not use 6%. Otherwise, doing 6% per month is just insanely good rate. So the trust fund matures. So matures basically says you can collect your money at the end of each month. Well, no, sorry. Matures kind of means it increases its value at the end of the month for the final investment, so 25 years after her first investment. This means that Betty makes 300 monthly investments. That was nice of them to tell you that. They could have said 25 years and you have to do 25 times 12, but it equals 300, so we've got 300 months. So after 25 years, what was the value of the first $80? So the question is not asking how much money would you have after those 25 years, it's just talking about that first amount. So this is really just compound interest. This first amount, remember, we call that A1. We put in $80, and because we're putting it in at the start of the first month, so that means it's going to get that 1.005. Okay, so it's increased by 0.5% 300 times, so it's going to be the power of 300. So it's not increasing only by 1 month, one lot of months worth of interest. We've got 300 months, and then so when you sub that all in, you get $357.20. And that's only the first installment of money. So there's going to be 299 other installments of money, which we're about to find in a second, how much money that is. But the question is also asking, how much does the first 80 grow by? So looking at question B now, by writing a geometric series for the value of all Betty's investments, calculate the final value of the trust fund. So what we need to do now is we've just gone and found that A1, that first installment, gets that. So the second installment, let's call that A2, will be another $80, 1.005. And that's going to be to the power of 299. We're just going to get one less month's worth of interest because we put it in 1 month later. That means A3 will be 80 lots of 1.005 to the power of 298, and so on. If we skip just a few, like 200 and something, we go to the 300th one, so that's going to be the last installment. That is still going to pick up 0.5% of interest, but it's only going to be 1 month's worth because we're putting it in at the beginning of each month. Now, if we were putting it at the end of each month, of course, that last $80 isn't going to get any interest. As we talked about, you can't just put in some money on the 31st of December and hope to get interest on the January 1st. You have to let it grow a little bit. So what we're trying to do now is we want to add up all those 300 terms. And of course, you don't want to sit there with a calculator adding them all up. We want to put this into a series. So the total is going to be 80 1.005 plus 80 1.005 to the power 2 plus plus that first installment 80 1.005 to the power 300. Remember, we like to do it in reverse here because generally making it a divergent series is going to be easier than making a convergent series. So I've flipped it around, so that's A300, that's A299, that's A1. Okay? So we're adding up all those installments. And then at this point we can also factorize here. So we'll take out the common factor of 80. We'll also take out a common factor of 1.005. So when we factorize that, we're left with 1 plus, because that 1 is just straight in that. When we take out this, we'll have a 1 So 1.005. The next one will be 1.005 squared. And the last one will be 1.005 to the power of 299. So remember, it's going to be 299 because for this one, we took out one of the 1.005, so we've still got 299 left over. And then in that second bracket we see there, that second big bracket, it's a geometric series. So here we have A equals 1, R equals 1.005, and N equals 300. Even though the highest power is 299, the lowest power is 0. Okay, so there are still 300 terms in there. When we factorize, we didn't immediately get rid of one of the terms, it's still there. So the sum of this, when you put it into the formula, so S300 in this section here, it's going to be 1 times 1.005 to the power of 300 minus 1 over 0.005, because that's 1.005 minus 1. And when you get that, you get that equals 692.9939. And then remember, we want to store that as A. We don't want to do any rounding yet. Let's just store that as A in our calculator. And so therefore, this whole that whole bracket there is just equal to A. So therefore our total, just scroll back up, our total we just said was 80 1.005 times whatever A was. And so when you put that into your calculator, you'll get 55716.71. And that's your answer. So quite a bit of work into it, but it just follows that same kind of procedure of listing out all the terms, factorizing and collecting it, making a little geometric series, and then finding that mini sum, timesing it by whatever you have left. And what we're saying here is, by putting in $80 into a bank account at the start of each month for 25 years, with all the interest that's added up into it, we get $55,716.71. Not too bad. And last question, and so that was an annuities question, so now we're talking about a loan repayment question. So Ryan borrows $300,000 to buy an apartment in which he repays monthly. So let's just again identify the keywords. So he's borrowed $300,000. Who cares what his name is or to buy an apartment, but he's repaying monthly. If the interest is 6% per annum, so again 0.5%, alright, per month, because we need to be doing months, because we said months, it's over 20 years. Find the value of each monthly repayment. Alright, that's basically what the question boils down to. So with the annuity question, we kind of thought we're trying to add up all the different terms. In this question, we want to think about kind of the opposite. First of all, our A1, if we call this A1, each of our A's is going to represent how much money is left over in this repayment, in this loan, after N years. Alright, N months, sorry. So when I'm saying N months, those 20 years is going to be 240 months. So it means we're going to have 240 terms. So the first one is just simply we've got that 300,000. It's increased by 1.005 because it's increased by that 5%. And then we took away some payment. So P is a monthly repayment. That's what we're trying to find. So from that, the value of A2 now, remember we talked about is, that's, to do A1, at the start of A1, that's how much we owe. So at the start of A2, we owe A1, that increases by 1.005. And then we take away another one of those P's. So now if we sub in A1, what it was a second ago, so 300,000, 1.005 minus P, we're multiplying that by 1.005 and we're minusing that by P. If we expand it, we'll get 300,000 1.005 to the power of 2 minus p lots of 1.005 minus p, so we've just expanded that set of brackets. And then remember, we want to factorize those p's at the end, so we get 300,000 1.005 to the power of 2 minus p 1 plus 1.005. Again, remember, it helps to reverse the order. Now that we've done that, we can kind of skip a few. First of all, we know there's going to be 240 repayments. So we will go down to 240. And A240 is going to be 300,000. 1.005 to the power of 240 minus p lots of 1 plus 1.005 plus, and then the last one is going to be 1.005 to the power of 239. Because remember, when we do this pattern recognition thing with the previous one, we saw that that was 2. Yeah, that was A2, so that was 2, that was 2, and that was 1, so it was 1 less than whatever the subscript was, so that's an n minus 1. So that's why in that one it's going to be 239. So, once we have that, we know that this, because this is how much is owing after the 240th month, which is the end, that means we know this has to equal 0. So, we're saying, really, that equals 0. And we want to find p, so how about we're going to add that bit on the right side over, we're going to add that over. So we have p 1 plus 1.005 plus plus 1.005 to the power of 239. That equals 300,000 1.005 to the power of 240. And again, we're going to talk about this mini-series in here. So this mini-series, we have A equals 1, R equals 1.005, N equals 240. So when we do that FM formula again, I'm just going to skip the whole working bit, but we get this to, so this S240 is going to equal 462.0408, so let's call that A. And therefore, our P, if we know that all of this is that A, we can just divide it over. So we have P equals 300,000, 1.005 to the power of 240, dividing it by A, and then when you get that in, you get $2,149.29. Meaning that this person, Ryan, is it Ryan? I forgot the name now. Doesn't matter. Yeah, Ryan needs to pay $2,149.29 at the end of each month for 20 years to pay off that loan. Okay? So the way we've done that is by thinking about how much is owed after the first month, how much is owed after the second month. By using that second month when we kind of develop a pattern to see how much is owed in that last month. So after 240 months, and we know that equals 0. And then from that, we just rearrange it, minus it, plus it over. Think of that mini-series, find that, divide by it, and we'll get our answer. So fairly run-of-the-mill question in terms of loan repayments. But as you see, there's quite a bit to it. It's just really a matter of knowing the procedure. So with annuities, you're kind of adding them all up, where with loan repayments, you want to get to the end where it equals 0. Anyway, so hopefully this video has been helpful. Make sure you rewatch any of the parts that you might be stuck on. But like these questions that we kind of covered in here covers basically any question you could really be asked. So the only other thing that they could ask is maybe in like a loan repayment question or annuity question, they might add like an extra little element to it. But that will make it like a question 15 or 16 question, which we can talk about in a bit more detail. But this is your basic kind of questions, your basic to intermediate style questions. So hopefully it's been helpful. If you have any more questions, make sure you ask.